Okay, good day. So Physics 1 class, we were going to perform today our experiment number 2, which is on the resolution of forces. So we entitled it, again, experiment number 2 as resolution of forces. So allow me to share a template so we'll be able to understand the objectives and the things that we're about to do for this experiment. Now, paired with our experiment, now is our knowledge on the graphical approach, the graphical method that we've learned in class. So the graphical approach, as you will recall it, we mentioned it in our lecture on the 3 different cases, case 1, 2, and 3, and including case number 4. So we resolve our forces there by presenting a graphical method and an analytical method. So, but for our activity today, we'll only employ one which will use a simulator, a fetch simulator, and I'm going to let you see in a short while. And then the other method that we're going to compare it with is the use of um, our graphical approach. So you're going to prepare your ruler, protractor for this activity. So to start with, allow me to go to this activity. Again, this is lab experiment number 2, and this is on the resolution of forces. Now our objective again is to determine the resultant force of 2 forces. And we are going to use the PhET simulator and the mathematical, or no, sorry, that should be the graphical method. Okay, so something is amiss there. So we're going to correct it in a short while. And for our materials, we are going to use a ruler for the graphical approach, the protractor, the pencil, the ball pen, and maybe when we try to determine the result eventually, we are going to use the ratio of our scale, and we are going to use our calculator to find the final value. Now, in comparison to the graphical approach, we are going to use the PhET simulator. It will be regarding about addition of vectors. And again, we will use the simulator there. Now, for our diagram, so we are going to get a picture of our simulator, and then at the same time, get a picture also of what you've drawn on the piece of paper using the graphical approach. Now, so basically the activity goes like this. So if we are going to go to the simulator now, so here's a picture of our simulator. And we can actually now load it up when we will try to perform it. So you can find that one in our module. So if you'll try to check in the sequence of our modules, we'll see it somewhere included in the laboratory portion. So the laboratory activities includes the uploaded resultant force, finding the resultant force using the PhET simulator. Now, we call, by the way, a force as also a kind of a vector. So it's one of the many examples of vectors. So we have displacement, we have velocity. But as our activity and in emphasis of the vector, we will use forces instead. So this is how we open up our vector, our vector simulator. And we will be going into the laboratory portion, so that we'll be able to see this one. Now, for our activity, so we'll be measuring actually, the values of the resultant of 3 different trials. And 3 different trials involves basically forces that have basically includes F1 and F2. The magnitudes of F1 and F2 are not changed, and what we change eventually are its direction. So for trial 1, for example, we deal with F1 going east and F2 going east. So they are going in the same direction. For trial 2, then we have 2 opposite directions here. one for F1, no? And one for F sub 2, which is basically 70 newtons. No? Now, all of this, guys, no, you are going to create a graphical answer. No? So you will draw using the tip to tail method. No? And I've been emphasizing the graphical approach as tip to tail. Now, once you get the resultant, no, for all these three trials, then you write all your answers over here. No? So the first value will, of course, include, no, your resultant, no, the length, the magnitude of the resultant, and then the other value should also include the angle or the direction. No? Okay, so two things to include. No? Now, the values that we've been drawing, no, and we measure the resultant by using the ruler and protractor, will be compared with our PhET simulator. No? So after you've done drawing all these three, no, in one paper. Now, by the way, the answer that you get there, now you're going to get a picture of that and then post one of that over at the diagram. No? So just make it clean, please. And then the other picture, which we will also include in our computation, will be placed over here. No? So while you make your picture of the graphical approach, you know, displayed here, then you are to calculate the length now by using the ratio or the scale that you are using. No? So that value, again, no, will be recorded over here. No? Now, our resultant force, no, which is using the PhET simulator. So we'll go to the PhET simulator now. So granting that we are dealing with a force, guys. No? So let me use an annotator here. No? So first of all, we will have to use some given values. No? So let's say we have F1 value to be equivalent to, let's say, let's say you'll use 60, no? 60 newtons, and it goes east, no? And then F2 is perhaps, no? That's another, no? Let's say 70, or no. Let's say we'll use instead 40, no? 40 newtons, and then east, no? Again, the simulator allows us to, no, plot both of these vectors in that specific direction. Now, we are going to drag one vector here, and let's say the vector that we will be using is the blue one. No? And again, the vector, guys, can be anchored on the origin because this is the point where we all start. No? So we anchor that vector there. So the tail of the vector now is on the origin. And we can stretch this length, no, of our vector, no, and point it in the direction of the force that we want to indicate. No? Now, if you check, no, the length of the vector is being shown over here. So right now, it's 18.4. No? So if you're going to plot it flat, no, on this line, this is roughly around 18. No? This one is 15, as you can see. No? And there's an angle there that's 0, that is 0 degrees. No? So every time we try to rotate this, the angle will increase. Every time we pull this up, then the length of the vector also increases. So for our first force, we will design it at 60 going east. No? So that's roughly 6.1. We will try to use, no, exactly 6. 6. So we now have 6. It is 0 degrees, so therefore it is exactly east. No? And then, so that's the first vector, force 1. And then we are going to connect vector 2. No? So at the tip of the vector, no, 1, we connect vector 2 and determine 40 newtons. So if one unit is 10 newtons, then we need here 4. So here is our 4. No? If you'll see, this one is 4. Our previous value is 6. No? They are both 0 degrees, so they are both east, because east is 0 degrees. Now, how do you get the resultant? No? So again, by clicking the sum over here, you'll see that the resultant now is being given with a certain length. No? So if you try to click this one, you'll notice that it will give a value 10, which is equivalent to the resultant. No? So its direction is again still 0. Again, if you click this vector, then it will give you the length of the vector plus its direction. So next vector is 4. And again, if each unit is 10, then that's 40 already at 0 degrees. So they are both 0 degrees. And here's our resultant drawn upward, but we can actually connect it here to really see the resultant. So again, now we can see the resultant by clicking this button. So the button there allows you to display the resultant. And the resultant again is, its values now are shown a while ago. So any questions so far? So you're going to do this for 3 different trials, but you vary the angle. Again, varying the angle is simply to rotate the arrow using the tip. So again, if this is our vector, guys, we can actually move the arrow here not to transfer it. But you'll notice that this one is moving because this one is now considering basically 3 vectors there. But for our case today, we'll only deal with 2. So if you don't need this, then you can put it back. Okay, so again, that's how we use the simulator. So don't forget to click this button and also to drag this button over this drawing. So again, now going back to our activity. So we'll complete this one. Once we've recorded all the PhET simulator values, and also the graphical method, then we are going to compare the magnitude only. So resultant force Fnet, resultant force math, or actually graphical is displayed, guys, or ang values ng aton lang ang magnitude. So this will only include the magnitude. Now for the percent difference, we will be subtracting the computed and the graph values of our resultant. So the magnitude only. And again, mark the percent difference there. Okay, so please make sure that you write your computation. Make sure that you complete this one also. So for your procedure, you can follow simply the activity that I illustrated using this video. So again, hopefully you understand the activity, and God bless everyone for your activity today.